Hello everyone and welcome back to Lesson 4, AI Ethics. In this video, we're going to be talking about explainable AI. So let's get right into it. So as AI becomes more prominent in our society, especially with better and more complicated technology like deep learning, it's important for us to understand how it works and why it makes its decisions. So there's three main benefits of developing explainable AI, and we're going to take a closer look at each one of them. First up, we have bias prevention. So we talked about this in the last video, which you should definitely check out if you haven't already. But bias in AI can come around in sneaky and frightening ways, and it can even have devastating consequences on people's lives. Being able to explain AI helps to pinpoint where things go south, which is useful in future improvements and preventing mistakes before it is too late. And then this also brings me into our next point, user trust. When we use AI in high-stakes situations, it is important that the users can trust it and feel comfortable with its decisions. We can use AI in things like possibly life-threatening medical conditions, finding new medicines, identifying criminals with facial detection algorithms, and more. And so when we are in these situations that can have profound impacts on people's lives, we need to make sure that not just us as the developers, but also the users can trust it. And finally, we have new discoveries. Especially now with deep learning, AI may pick up patterns that we never thought of before. Noticing these patterns allows researchers to find more efficient ways of performing the original task, and it can help us to train smarter AI models that now know these new patterns right from the start of training. So as you can see, there's definitely a lot of benefits of explainable AI, and it generally makes us more comfortable and less skeptical as we start employing these new technologies. So now the question is, how do we develop explainable AI? Okay, so now let's look at three methods to better understand our AI. First up, we have confusion matrices, which help us to understand where data is sorted versus where it should be sorted. And if you remember, as we discussed in Lesson 3, matrices are grids consisting of rows and columns. So here's a quick example. This matrix shows the outcome of sorting 50 objects by color, whether it's red, blue, or green. What do you notice going on here? Maybe take a moment to pause the video and think about these patterns. Okay, so hopefully you're back and you've thought of some patterns on your own. Now let's take a closer look at it together. So I'm going to grab my pen tool so that I can go ahead and show you guys these things. So here we notice, right, that all of the columns represented the objects that are sorted, and all of the rows represented their actual colors. And now, if you look at this diagonal right here, consisting of the numbers 21, 8, and 10, that represents all of the objects that were sorted correctly. So we have 21 objects that were sorted correctly as red, 8 objects that were correctly sorted as green, and 10 objects that were correctly sorted as blue. So that means we have a total of 39 objects that were correctly sorted out of 50, which is a pretty good accuracy. But now let's go ahead and examine where things went wrong. So first, observing the general row of red, right, we have 21 reds that were sorted correctly and 1 that was sorted incorrectly in green. So that means we have a pretty good accuracy for red. And if we look at the sorted column for red, right, we notice that the only incorrectly sorted red was actually blue. So again, we're having a pretty fair accuracy for the red objects. Now let's move on to green. So for the green, we have 12 total objects, right? And as we can see, 8 of them were sorted correctly. But also, 4 greens were sorted incorrectly in blue. And finally, if we move on to the blue row, we have 10 blue objects that were correctly sorted, but then we have 6 that were incorrectly sorted. 5 of them got mixed up in green, and 1 of them got mixed up in red. So overall, by looking at this visualization, it helps us to realize that our accuracy of red is pretty good, but our accuracy of green and blue can be improved. And right here, right, we see a lot of confusion, and the model is more likely to mix up green and blue. And if we take a closer look at the actual data, right, we notice that there's 22 examples of red, but there's only 12 examples of green and only 16 examples of blue. So maybe that indicates to us that we need to have more green and blue data, and maybe after retraining the model, it will perform better. So even though I know this may seem like just a jumble of numbers at first, constructing a confusion matrix can actually be really helpful in not only noticing how the AI is making a mistake, but also where it's making a mistake and subsequently improving our dataset. So now let's move on to saliency maps. Saliency maps help to understand how AI makes decisions when dealing with computer vision and analyzing a specific image. The map uses different colors to indicate how important each pixel was in making the final decision. So even if the AI model works correctly, we can assess whether it can pick out relevant features or not. And so with the colors in a saliency map, it sort of looks like a heat imaging map or a geographical map. And so darker shades mean the AI is prioritizing the portion of the image more when making its decision. And so this can help us to understand if it's looking at relevant features. So for example, if in a facial algorithm, the pixels are darker around eyes, nose, lips, and the overall bone structure, then we know that it has the right idea. But if it's highlighting something in the background of the image, then we know that it is flawed. So even if the overall decision may be possibly correct, it still helps us to realize whether it is thinking in the way that we want it to. And finally, we have surrogate models. They're also referred to as meta models because they model how another model works. And it's a special case of supervised machine learning. So once we create our initial AI model and find success, we can form another model to explain how the first one worked. And so we put in the inputs and outputs determined by the first model, and then the surrogate model will be trained so we can track how the decisions are made. And so surrogate models often use machine learning instead of deep learning. And deep learning usually has higher accuracy rates than machine learning. But at the same time, because of so many neurons and connections involved, deep learning is harder to explain. So it's better if we use a more complex yet harder to explain model to get the desired results. And then we use an easier but possibly less accurate model to then piggyback off of the first one. Okay, so we covered a lot in this video. Let's go ahead and summarize it all up. So as new methods of training AI models become more efficient and complicated, it can become hard to fully understand AI. However, explainable AI is crucial in reducing bias, ensuring user trust, and furthering AI research with the newest discoveries. And some ways to explain AI include confusion matrices, saliency maps, and surrogate models. And we're definitely trying to develop even better technology so that we can truly understand what our AI is thinking. Okay, so I think that's all for today's video. Thank you so much for watching. It has been a pleasure learning all of this with you guys, and I hope that you enjoyed. Next up, we have Lesson 5, Video 1 on Everyday AI. So I will see you there. Bye!